This is actually two poems for calculus about the first derivative test and the second derivative test. See if you can anticipate the rhyme before I say it. Let's take a few moments to sketch out in rhyme exactly what you know when you've got f prime. For example, when positive, it's visually pleasing, and the graph of the function is clearly increasing. But if it's below zero, like days that are freezing, the graph of the function must now be decreasing. When f prime is zero, it is not political to say that the point you have found is called critical. Yet there's a lot more, as you may have guessed, a thing called the first derivative test. Find a critical point and consider the facts. If it goes plus to minus, you must have a max. If those signs are reversed, it's really no sin. You've stumbled across a point that's a min. And lastly, if f prime has no change of direction, the critical point is a point of inflection. Now, if you want to continue to something sublime, consider the meaning of f double prime. If it's positive, the function is shaped like a cup, for the slope is increasing and the graph's concave up. And negative values will make functions frown. When the slope's getting smaller, the graph's concave down. But f double prime won't help us to know the concavity if its value's 0. See, the derivative's power is really not strange, for it gives you the lowdown on how functions change. But if f prime is 0, it would be best to apply the second derivative test. If the second derivative's positive, it must be grinning. The concavity is up, so the function is minning. And if less than 0, it's surely not taxing. The graph's concave down, so the function is maxing. But if it's equal to 0, we have no direction as to max min neither, or point of inflection.